potential problem exists concerning the use of 2/3 SEU aluminum cable to feed a 100 amp panel and a double-pole double-throw center-off non-fusible switch. The National Electrical Code, specifically Table 310.15b16, dictates the minimum ampacity of a 2/3 SEU aluminum cable is 75 amps. Utilizing a 2/3 SEU aluminum cable to supply a 100 amp circuit might not be sufficient, thus creating a potential hazard. Several solutions are available to address this issue. Firstly, consider replacing the 2/3 SEU aluminum cable with a larger size cable. A cable with an ampacity of at least 100 amps, such as 4/0 SEU aluminum, is a viable option. Secondly, you could install a fuse or circuit breaker as an overcurrent protection device. Place a fuse or circuit breaker with a rating of 100 amps in the panel or switch that is being fed by the 2/3 SEU aluminum cable. Thirdly, reducing the load on the circuit is another possible solution. If feasible, decrease the load on the circuit that is being fed by the 2/3 SEU aluminum cable to a level that is less than or equal to 75 amps. Additional considerations include assessing the adequacy of existing wiring. The 6 feet of 4/0 SEU aluminum and the 8 feet of 2/3 SEU aluminum from the meter socket to the two main breaker panels are likely adequate for the respective loads. The 2-foot run of 2/3 SEU aluminum from the double throw switch to the 100 amp main breaker panel is also likely adequate, provided the load is limited to 75 amps or less. It is essential to ensure that all wiring complies with the National Electrical Code and local building codes. Obtaining an electrical permit may also be a requirement for the installation. Let's delve deeper into the reasoning behind these solutions and the importance of adhering to electrical codes. The National Electrical Code is a comprehensive set of standards designed to ensure the safe installation and operation of electrical systems. It is developed and maintained by the National Fire Protection Association and is widely adopted throughout the United States. The NEC provides specific guidelines for conductor ampacity, which is the maximum amount of current, measured in amps, that a conductor can safely carry continuously under specific conditions of use without exceeding its temperature rating. Ampacity is determined by several factors, including the conductor material, size, insulation type, and ambient temperature. Table 310.15b16 in the NEC provides ampacity ratings for various types of conductors based on these factors. When selecting conductors for an electrical installation, it is crucial to choose conductors with an ampacity that is equal to or greater than the calculated load current. This ensures that the conductors can safely carry the required current without overheating, which can lead to insulation damage, fire hazards, and equipment failure. In the scenario described, the 2/3 SEU aluminum cable has an ampacity of 75 amps according to NEC Table 310.15b16. This means that the cable is only rated to carry a maximum continuous current of 75 amps. If the cable is used to feed a 100 amp panel or switch, it may be overloaded, which can cause the cable to overheat and potentially fail. To address this issue, several solutions can be implemented. The first solution is to replace the 2/3 SEU aluminum cable with a larger size cable that has an ampacity of at least 100 amps. A 4/0 SEU aluminum cable, for example, has an ampacity of 180 amps, which is more than sufficient to handle a 100 amp load. When selecting a larger size cable, it is important to ensure that the cable is properly sized for the load and that it is installed in accordance with the NEC and local building codes. The second solution is to install a fuse or circuit breaker with the rating of 100 amps on the panel or switch that is being fed by the 2/3 SEU aluminum cable. A fuse or circuit breaker is an overcurrent protection device that is designed to protect electrical circuits from damage caused by excessive current flow. When the current in a circuit exceeds the rating of the fuse or circuit breaker, the device will trip, interrupting the flow of current and preventing damage to the circuit. By installing a 100 amp fuse or circuit breaker on the panel or switch that is being fed by the 2/3 SEU aluminum cable, the cable will be protected from overload. If the current in the circuit exceeds 100 amps, the fuse or circuit breaker will trip, preventing the cable from overheating and potentially failing. The third solution is to reduce the load in the circuit that is being fed by the 2/3 SEU aluminum cable to a level that is less than or equal to 75 amps. This can be achieved by disconnecting some of the loads that are connected to the circuit or by using more energy-efficient appliances and equipment. By reducing the load in the circuit, the current flowing through the 2/3 SEU aluminum cable will be reduced, which will decrease the risk of overheating and failure. In addition to these solutions, it is also important to consider the additional factors that can affect the ampacity of conductors, such as ambient temperature and the number of conductors in a raceway or cable. The NEC provides specific guidelines for directing conductor ampacity based on these factors. For example, if the ambient temperature is higher than 86 degrees Fahrenheit, the ampacity of the conductors must be directed. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be directed. It is important to consult the NEC for specific directing factors and to apply them as necessary to ensure that the conductors are properly sized for the load. Furthermore, it is crucial to ensure that all wiring is installed in accordance with the NEC and local building codes. This includes using the correct wiring methods, properly supporting and securing the conductors, and making proper terminations. Improper wiring can lead to a variety of problems, including electrical shocks, fire hazards, and equipment failure. Finally, it is important to note that an electrical permit may be required for the installation. Electrical permits are typically required for new electrical installations, alterations, and repairs. The purpose of an electrical permit is to ensure that the work is performed in accordance with the NEC and local building codes and that it is inspected by a qualified electrical inspector. Obtaining an electrical permit can help to ensure that the electrical installation is safe and compliant with all applicable regulations. In summary, the use of 2/3 SEU aluminum cable to feed a 100 amp panel switch poses a potential problem because the cable has an ampacity of only 75 amps. To address this issue, several solutions can be implemented, including replacing the cable with a larger size cable, installing a fuse or circuit breaker, and reducing the load on the circuit. It is also important to consider additional factors that can affect the ampacity of conductors, such as ambient temperature and the number of conductors in a raceway or cable. By following the NEC and local building codes and obtaining an electrical permit, you can help to ensure that the electrical installation is safe and compliant with all applicable regulations. Now let's consider the specifics of the described installation. The 6 feet of 4/0 SEU aluminum cable from the meter socket to the 200 amp main breaker panel is likely adequate, as 4/0 aluminum is typically rated for 180 amps or more, depending on the insulation type and termination temperature rating, according to NEC Table 310.15b16. The 8 feet of 2/3 SEU aluminum cable from the meter socket to the 100 amp main breaker panel presents the issue previously discussed. Since 2/3 SEU aluminum is rated for 75 amps, it is undersized for a 100 amp breaker. The recommendation would be to upgrade this section to a cable with a higher ampacity or protect it with a smaller overcurrent device as described above. The 13 feet of 2/3 SEU aluminum cable from the meter socket to the double pole double throw switch also presents the same concern if the intent is to supply more than 75 amps through the switch. If the double throw switch is used to select between 2 different power sources, and each source is protected at 75 amps or less, then the 2/3 SEU aluminum might be acceptable. The 2-foot run of 2/3 SEU aluminum cable from the double throw switch to the 100 amp main breaker panel is again only adequate if the load is strictly limited to 75 amps or less. Since it is connected to a 100 amp breaker, there is a potential for overload. Again, consider a larger cable or a smaller overcurrent protection device. It is important to remember that these are general guidelines, and the specific requirements for any electrical installation will depend on the specific circumstances and the applicable codes and regulations. It is always recommended to consult with a qualified electrician to ensure that the electrical installation is safe and compliant. Let's explore further the concept of overcurrent protection. Overcurrent protection is a critical safety feature in any electrical system. Its primary purpose is to protect conductors and equipment from damage caused by excessive current flow. Overcurrent can result from various factors, including short circuits, ground faults, and overloads. Short circuits occur when there is an unintended low resistance path between two conductors. This can cause a large amount of current to flow very quickly, which can damage conductors and equipment. Ground faults occur when there is an unintended path between a conductor and ground. This can also cause a large amount of current to flow, which can be dangerous. Overloads occur when the current in a circuit exceeds the ampacity of the conductors. This can cause the conductors to overheat and potentially fail. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current when an overcurrent condition occurs. Fuses are one-time devices that contain a fusible link that melts and opens the circuit when the current exceeds the fuse's rating. Circuit breakers are reusable devices that use a bimetallic strip or a magnetic field to trip and open the circuit when the current exceeds the breaker's rating. There are two main types of circuit breakers: thermal magnetic and electronic trip. Thermal magnetic circuit breakers use a thermal element to protect against overloads and a magnetic element to protect against short circuits. Electronic trip circuit breakers use electronic circuitry to detect overcurrent conditions and trip the breaker. When selecting overcurrent protection devices, it is important to choose devices that are properly sized for the circuit and that are approved for use in the specific application. The NEC provides specific guidelines for selecting overcurrent protection devices, including the maximum allowable ampacity of the device and the type of device that is required for specific applications. It is also important to ensure that the overcurrent protection devices are properly installed and maintained. This includes verifying that the devices are properly connected and that they are functioning correctly. Regular testing of overcurrent protection devices is recommended to ensure that they will trip when an overcurrent condition occurs. In addition to overcurrent protection devices, other safety features can be incorporated into electrical systems to protect against electrical hazards. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against electrical shocks. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than 5 mA between the two currents, the GFCI will trip and interrupt the flow of current. Arc fault circuit interrupters, or FSIs, are devices that are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when there is an unintended arc of electricity between two conductors. FSIs detect the unique characteristics of arcing faults and trip the circuit to prevent a fire. Surge protective devices, or SPDs, are devices that are designed to protect against voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD divert the excess voltage away from sensitive electronic equipment, protecting it from damage. By incorporating these safety features into electrical systems, it is possible to significantly reduce the risk of electrical hazards. Now, let's address the specific implications of using aluminum conductors. Aluminum conductors are commonly used in electrical wiring due to their lower cost and lighter weight compared to copper conductors. However, aluminum conductors have some unique characteristics that must be considered when designing and installing electrical systems. One important consideration is the coefficient of thermal expansion. Aluminum has a higher coefficient of thermal expansion than copper, which means that it expands and contracts more with changes in temperature. This can lead to loose connections over time, which can cause overheating and fire hazards. To prevent this, it is important to use connectors that are specifically designed for use with aluminum conductors. These connectors are typically made of aluminum or a bimetallic material that is compatible with both aluminum and copper. Another important consideration is the oxide layer that forms on the surface of aluminum conductors. Aluminum oxide is a poor conductor of electricity, so it can impede the flow of current. To prevent this, it is important to clean the aluminum conductors thoroughly before making connections. This can be done using a wire brush or a chemical cleaner that is specifically designed for use with aluminum conductors. It is also important to use an antioxidant compound when making connections with aluminum conductors. Antioxidant compounds help to prevent the formation of aluminum oxide and improve the conductivity of the connection. When installing aluminum conductors, it is important to follow the manufacturer's instructions and the applicable codes and regulations. This includes using the correct wiring methods, properly supporting and securing the conductors, and making proper terminations. It is also important to inspect the aluminum conductors regularly for signs of corrosion or damage. If any problems are found, they should be corrected immediately to prevent electrical hazards. In addition to these considerations, it is also important to be aware of the specific requirements for aluminum conductors in the NEC. The NEC provides specific guidelines for the ampacity of aluminum conductors, the types of connectors that are allowed to be used with aluminum conductors, and the methods for installing aluminum conductors. By following these guidelines, it is possible to ensure that aluminum conductors are installed safely and reliably. One notable difference between aluminum and copper wiring pertains to the required ampacity for a given wire gauge. Aluminum wire generally requires a larger gauge than copper to carry the same amount of current safely. This is due to aluminum's lower conductivity compared to copper. Therefore, when replacing copper wiring with aluminum, it is essential to increase the wire gauge accordingly to maintain the same ampacity. For example, if a circuit is currently wired with 12-gauge copper wire, which is typically rated for 20 amps, it would need to be replaced with 10-gauge aluminum wire to maintain the same 20-amp capacity. Consulting the NEC tables for conductor ampacity is crucial for determining the appropriate wire gauge for aluminum conductors based on the intended current load. Another crucial aspect is the compatibility of devices and equipment with aluminum wiring. Not all electrical devices, such as outlets, switches, and circuit breakers, are designed to be used with aluminum wiring. Using incompatible devices can lead to corrosion, overheating, and even fire hazards. When working with aluminum wiring, it is essential to use devices that are specifically listed and labeled for use with aluminum conductors. These devices are typically marked with the letters ALCU, indicating that they are suitable for use with both aluminum and copper wiring. Furthermore, special care should be taken when terminating aluminum wiring to prevent corrosion and ensure a secure connection. Using the proper tools and techniques, such as applying an antioxidant compound and tightening the connections to the specified torque, is crucial for maintaining the integrity of the electrical system. In summary, working with aluminum wiring requires careful consideration and adherence to specific guidelines to ensure safety and reliability. By understanding the unique characteristics of aluminum conductors, using compatible devices and equipment, and following proper installation techniques, it is possible to create a safe and efficient electrical system using aluminum wiring. Also remember the location of this potential issue is Rochester, Minnesota.